Hello, this is the final practice test for Algebra second semester. A few reminders. We have some due dates coming up on June 11th. That is the teacher graded assignment deadline at 11:59 p.m. June 14th, that is when our math final is set to be taken. That is also the computer graded assignment deadline at 11:59 p.m. and that is the last day of school. For missing assignments, you want to check your gradebook for any missing assignments. Retakes, check your gradebook for low quiz scores that have remaining attempts. Make sure you're reading the feedbacks. You want to check your teacher graded feedback to see if you submitted the wrong test page and if you can resubmit it. Remember, if you want to be exempt from the final exam, if you have turned in everything and have an A, you will be exempt. So your official confirmation will be emailed to you on Wednesday, June 12th. For the final practice test review, so what you need today is you need the final practice test. So you want to print out the practice test and just write directly on the paper. You will not be turning in this practice test. However, you should show all your work for all the problems and take very good notes because this practice test is very similar to the actual final test that you will be taking. So you can use this practice test while you're taking the final. So while the problems on the practice test are very similar to the final exam, pay attention because it's just going to be with different numbers and different values used. So why should you be here? Well, all the problems on the practice test are almost identical to the final. Same problems, just different numbers. The recording is going to show you all the work needed for each problem and the solutions. And then you can use your practice test as notes. So you have a sample problem to help you with each problem on the actual test. So let's go ahead and take a look at number one here. For number one, we want to subtract two polynomials, 6x squared plus 7x minus 3, all minus another polynomial, 3x squared minus 2x plus 4. So for this problem, you're going to be entering your answer in the box. So each of the problems tell you what you're going to be doing or what type of question it's going to be when you're taking the actual final. So what we need to do here in order to subtract polynomials is we first want to get rid of the parentheses. If we're subtracting polynomials, we need to distribute that negative sign to each term in the second polynomial. So we first just want to rewrite everything without the parentheses. So it's going to be 6x squared plus 7x minus 3. So that all stays the same. And then when we distribute the parentheses to the second polynomial, that becomes negative 3x squared. And when we distribute it to the second term, a negative times a negative becomes positive 2x, positive 2x, and then negative times a positive becomes negative 4. Now from here, we simply combine like terms. So we have a 6x squared, and we want to see if we have any other terms that have the x squared attached to it. And we do. So we have 6x squared minus 3x squared. 6x squared minus 3x squared is going to give us 3x squared. And then we have positive 7x plus 2x. So 7x plus 2x gives us 9x. Then we have negative 3 minus 4. So we're adding two negatives. So negative 3 minus 4 is going to give us negative 7. So now our final solution, we just want to check if we can combine any more like terms. 3x squared plus 9x minus 7. We have no more like terms. So this is our final solution. For number 2, we are asked what are the zeros of the function? So we're given the function f of x is equal to x cubed minus x squared minus 12x. This one's going to be a multiple choice question. So the first thing we want to do is we need to know what the zeros mean. So the zeros are the same as our x-intercepts. It's another way of saying the x-intercepts. Remember, x-intercepts are where the graph crosses the x-axis, and we only care about the x values of our points. So if we have a cubic function, which is what this is since we have the highest exponent of 3, that means there's going to be up to 3 x-intercepts. So what you can do here is you can plug in your equation into Desmos to see where the graph crosses the x-axis. You might need to zoom in or out just to get a clearer view of where it crosses the x-axis. But that's what we did here. We took our function x cubed minus x squared minus 12x, plugged it into Desmos.com, and this is the graph that we get. So we have 3 points where it crosses the x-axis, and all we care about are those x values. So it's just at x equals, we have right here, -3, x is equal to 0, and lastly, x is equal to 4. And those are the zeros of our function, because remember, zeros are the same thing as the x-intercepts. For number 3, we want to solve for x. If we're given 9x squared times y is equal to 64. This is going to be a multiple choice question, and a couple hints over here. So when we're solving for a variable, that means we want to get the variable by itself. So our ultimate goal is to isolate the x. Since it's asking us to solve for x, we want to isolate the x. Also remember, when we're taking the square root to solve an equation, we have to have a plus or minus in our answer. So now let's go ahead and look at our equation. I'm going to go ahead and just copy it down here. We have 9x squared y is equal to 64. Ultimate goal is to get the x by itself. So we need to look at what's being done to the x. We are multiplying the x squared times 9 and times the y. So what we first can do is we need to get rid of that 9 and the y by doing the opposite of multiplication, which in this case is division. So we're going to divide both sides by 9y. So those 9's divide out, those y's divide out. So that leaves us with x squared is equal to 64 over 9y. Now we want to check and see if we can simplify 64 over 9, and we cannot in this case. So now we're going to move on to the next step. We have x squared, and the inverse operation of x squared is to take the square root. So we're going to take the square root of this side. Whatever we do to one side, we have to do to the other. So now what we have is we have x is equal to, and this is where the second hint came into. When we take the square root, we're going to have plus or minus. So plus or minus, and we can go ahead and just separate this. So it's square root of 64 over square root of 9y. And then we simplify where we can. We can take the square root of 64, so that gives us 8. And we can take the square root of 9, so that gives us 3. But we can't take the square root of y, so that leaves us with the square root of y on the denominator. So now we're left with x is equal to plus or minus 8 over 3 times the square root of y. One of the rules of a fraction is that we cannot have a square root sign on the denominator. So what we have to do is we have to do something called rationalizing the denominator, and that means we're going to multiply both the numerator and denominator by the radical on the denominator. So by that radical y, or square root of y. So now what we have we have x is equal to plus or minus 8 times the square root of y on the numerator, and on the denominator we have 3, and then we have the square root of y times the square root of y. Now square root of y times the square root of y, I'll go ahead and put it here, becomes the square root of y squared. And the square root of y squared is just y. So that leaves us with x is equal to plus or minus 8 times the square root of y over 3y. And that's our solution. That's as far as we can simplify it. So that's it for number 3. For number 4, we want to let x squared plus 8x equal to 45, and we're asked what values make an equivalent number sentence after completing the square. So we're going to be entering our answers in 2 different places here. And what we need to do is we're just starting the process of completing the square. And remember, completing the square is allowing us to solve the problem by manipulating the equation to look different, but it doesn't actually change the equation, because whatever we do to one side, we're going to be doing to the other. So in order to figure out what our new c is, what's going to be going in this spot here, we take our b term, divide it by 2, and then square it. So our b term is always the number multiplied by the x. So in this case, it's that positive 8. So we're going to take our 8, divide it by 2, and then we're going to square it. So 8 divided by 2 is 4, and then when we square it, we're going to get 16. So that's the number that we're going to be adding in to that space there, is 16. Now on the other side of the equal sign, we're going to be adding in 16 there as well. However, we have to add it to the original constant that was on that side. So it's going to be 45 plus 16, and then we need to simplify that. So when we do that, we'll get so we have 16 on this side, and then when we add 45 plus 16, we get 61. So those are going to be the 2 things that we enter in to the spaces. And that's it for number 4. For number 5, we want to use the quadratic formula to solve the equation 2x squared minus 8x plus 5 is equal to 0. And you're going to want to enter your answers separately. Because remember, when you use a quadratic formula, we're going to have a plus, and then we have the plus or minus within the quadratic formula. So we have 2 solutions. So the first thing we want to do is we want to make sure it's in standard form. Ax squared plus bx plus c, which it is, so we're good to go. Now we can identify our a, our b, and our c. So our a is the number times the x squared, which is a 2. Our b is the number times the x, which is negative 8. And our c is a constant, which is 5. Now we simply plug them into our handy dandy quadratic formula over here and simplify. So we have x is equal to opposite b, so opposite of negative 8 plus or minus the square root of b squared, so negative 8 all squared minus 4 times a, 2 times c, which is 5, all over 2a, so 2 times 2. And now from here we simplify. So we first want to simplify everything underneath that radical, and then we can also do that negative times negative 8. So we have positive 8 plus or minus the square root of negative 8 squared, so negative 8 times negative 8 is positive 64, minus negative 4 times 2 is 8 times 5 is 40. So minus 40 all over 4. Still simplifying what's inside that or underneath that radical, we'll have 8 plus or minus square root of 64 minus 40 gives us 24 all over 4. Now from here, we need to see if we can simplify under that radical even further. So we can't take the square root of it nicely, but what we can do is we can break it up into two factors where we can take one of them nicely. So what that looks like is 24 can be rewritten as 4 times 6, and I chose 4 and 6 because 4 is a perfect square. Remember, when you're doing that, you want one of them to be a perfect square. All over 4. So now we can take that square root of 4. So we have x is equal to 8 plus or minus, the square root of 4 is 2, and we can't take the square root of 6 or simplify it any further, so that stays underneath, all over 4. Now from here, we need to see if we can simplify what's outside that radical any further. So notice that we have 4, we have a 4, we have an 8, and we have a 2. We can divide each of those numbers by 2. So 4 divided by 2 is going to give us 2. 8 divided by 2 gives us 4. And 2 divided by 2 gives us 1. So the only reason that we're allowed to simplify that is because we can divide each of those terms by 2. So we have to be able to divide each of them by that same number. So now if we just rewrite it using that, we have x is equal to 4 plus or minus 1, which we don't need to write the 1, times the square root of 6 all over 2. And we just want to enter our answers separately. There's nothing else we can do to reduce. We cannot reduce that 4 and the 2 because there's no number here that we can reduce. We can't reduce anything underneath that radical, so we simply enter our answer separately. So we have 4 plus square root of 6 all over 2, and then x is equal to 4 minus square root of 6 all over 2. And we have solved using the quadratic formula. For number 6, we're asked, what is the solution to the system of linear equations? So we have 6x minus 4y is equal to negative 24, and 4x minus 8y is equal to negative 32. So you're going to be entering your answers. Here we're using a linear combination. So the first thing we're going to do is make sure all the terms are aligned. All the x's are lined up on top of each other, the y's, equal signs, and then the constants. So in this case they are. Then we want to just combine the equations by adding down and see if anything gets eliminated. So if we do that real quick, 6x plus 4x gives us 10x minus 12y is equal to negative 56. So notice none of the terms get eliminated. So this means we need to manipulate one or possibly both of the equations to help eliminate a term. So looking at this, notice if we look at the y's here, we have negative 4y on the first equation and then negative 8y on the second equation. If we multiply that top equation by a 2, or in this case we want to make it a negative 2, so it's the opposite sign, that's going to give us a positive 8y, which will eliminate the y's. So what we're going to do, we can't just multiply the y's by that. We need to multiply the whole term by a negative 2. So when we do that, the top term, or the top equation, is now negative 12x plus 8y is equal to positive 48, and the bottom equation stays the same. So 4x minus 8y is equal to negative 32. Now if we add straight down, we have negative 12x plus 4x, so that gives us negative 8x. 8y minus 8y, those eliminate, is equal to 48 minus 32, gives us 16. Now we've eliminated the y value, so we can simply solve for x. So divide both sides by negative 8. We're going to get x is equal to negative 2. So now that we know what one variable is, we can substitute it into either of the original equations. You get to choose. We could do either the very first original equation or the second equation and solve for y. So let's go ahead. Either equation works, but let's go ahead and take x and plug it into the second equation for x. So that gives us 4 times negative 2 minus 8y is equal to negative 32. And now we simplify from here. 4 times negative 2 gives us negative 8 minus 8y is equal to negative 32. Add 8 to both sides of that equal sign. So we have negative 8y is equal to negative 32 plus 8 gives us negative 24. Divide both sides by negative 8. And we get y is equal to positive 3. So now we have our solution. We have written as an ordered pair, negative 2, comma 3. And we can check our solution by plugging it back into both of the original equations to make sure we get a true statement. So if we just do that, 6 times negative 2 is negative 12, minus 4 times 3, negative 12. So negative 12 minus 12 is negative 24. So beautiful. If we plug it into the second one, 4 times negative 2 is negative 8, minus 8 times 3, so minus 24, and that gives us negative 32. Perfect. So our solution is negative 2, comma 3. For number 7, we're going to solve the systems of equations. And when you're taking it, you're going to be just entering your answers as your solution. So we're given x plus y is equal to negative 4, and then y is equal to 2x squared plus 7x minus 4. So this is a great problem to use the graphing tool. So you want to use Desmos.com again. And when you plug in your two graphs, we get, or your two equations, we get these two graphs over here. And when we're solving, we're looking at where our graphs intersect. So the 2 points where our graphs intersect. So here and here. And our solution is those ordered pairs at which those graphs intersect. So this first one up here is at negative 4, comma 0, and the one down here is at 0, negative 4. And we just need to write our answers as ordered pairs. So we're just going to write those down over here. And that's it. So you just graph your two equations using Desmos.com, and then the two ordered pairs where the graphs intersect is your solution. For number 8, we're given that the graph shows the function f of x is equal to negative 6x minus 12 and g of x is equal to 1/2 all raised to the x power minus 4. What are the solutions to the equation f of x is equal to g of x? So the graph will already be given for you. And for this one, unlike number 7, where we graphed it and then we listed it as the ordered pairs, For number 8, you're only giving the x values. So when you're putting your answers in, you are only selecting the x values. You are not doing the ordered pairs like you did with number 7. So here we just look at the two x points where our graphs intersected. So the first one we have x is equal to at -4 and -2. So we only care about those x values. And those are our two solutions. So once again, for number 8, you're not listing it as an ordered pair. You're just giving it with the x values. For number 9, the equation h of t is equal to -16t squared plus 85t plus 25 gives the height of a firework in feet t seconds after it is launched from a platform. What is the height of the platform? And you're going to be entering your answer in. So the height of our platform is our starting or our initial point. So when our time is 0, because that's where we're starting here. So if we think about it, what happens when we plug in 0 for t? So let's go ahead and do that. So if we're looking at h of 0, it's going to be -16 times 0 squared plus 85 times 0 plus 25. So if we simplify this, notice we have 0 here. So 0 times anything, that's going to cancel out. 0 times anything is 0. So we have h of 0, so our initial starting point is going to be 25 feet. So this is our c value of our equation. So notice 25 was what our c value was of our original equation. So the height of our platform was 25 feet. For number 11, we're asked what are the zeros of the function. And this is just like number 2. So remember, zeros are the same thing as the x-intercept. So where it crosses the x-axis. And we're only going to put the x values of our points. Since we have a quadratic function, so the exponent's 2, we're going to have 2 x-intercepts. So what you want to do is you're going to use Desmos.com again. You're going to plug in your equation, so x squared minus 4x minus 45, and we're going to see where our graph crosses the x-axis. So in this case, we have the 2 points when x is negative 5 and x is 9. So at x is negative 5 and 9, and those are our 2 zeros of our function. For number 12, we're going to let f of x is equal to 5 to the x power and g of x equal 5 to the x minus 2, all plus 3. What transformations are needed to transform the graph f of x to the graph of g of x? So this question is going to be a drop-down menu, so you're going to click on it and then you're going to choose a selection from that drop-down. So we're going to look at the horizontal translation and the vertical translation from f of x to g of x. We can go ahead and graph these. We can use Desmos.com and graph our two functions, f of x, 5 to the x power, and g of x, 5 to the x minus 2 all plus 3 power. And then we can see what our translations are from there. So the red one, this is our f of x. This is our 5 to the x power, and this blue one up here, this is our 5 to the x minus 2 all plus 3 power. So what we want to do here is, let's first look at the horizontal translation, and let's see what we had to do to get from f of x all the way to g of x. So from this point, the starting point here, to over here. So if we notice, I know the grid has 4 little things here because it's just zoomed in a little bit extra, but if we notice, we go from 0 to 2. So we move to the right 2 units. So if it's with x, we move like x, but in the opposite direction. So notice here, our g of x, this negative 2 is with the x, so we move with the x, but in the opposite direction. So instead of being 2 units to the left, it's 2 units to the right. So we moved right 2 units. So we have a horizontal translation of 2 units to the right. Or right 2 units. And now from here, we're going to look at how did we get from this point to our point up here for our vertical translation. And if it's not with the x, so if it's just attached to our whole function, we move like y and we do exactly as it's saying. So this is saying positive 3, meaning we're going to move up 3. So let's go ahead and check. So we move up 1, 2, 3 units. So up 3 units, which is exactly what our function said. So we have a vertical translation of 3 units up, or up 3 units. And that's it for number 12. For number 13, we're given the graph represents the height y in feet above the ground of a rock x seconds after it is dropped from a building. Which statement or statements are true? So we can select each correct answer. So there is going to be more than one answer for this. So if we take a look at our graph, the starting point here is up at 45 feet. And then it goes down, goes down, goes down, goes down, and it hits the ground at 3 seconds. So then it's going down, 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 hits the ground here. So let's go ahead and look at each of our choices and see if it matches our graph. So the rock hits the ground at 45 seconds. If that was true, that means it would be hitting the ground like way over here, because 45 seconds is over here. So that first one is not true. So let's look at then the second one. Second one says the rock rises above 45 feet before falling towards the ground. If we look at the graph and the direction it takes, it starts at 45 feet and then it just starts going down. If it were to go up first and get above 45 feet, then it would take more. It would go up first and then go down. But it doesn't do that. So that second statement is also not true. 45 feet is the highest it goes. For the third one, the maximum height of the rock occurs at x is equal to 0. So x is equal to 0 right here, and if we look, that is the maximum height, that 45 feet. So this statement is true. So we can go ahead and check that one off. Do a better check mark there. All right, that fourth one. The rock is in the air for 3 seconds. So let's look at our time. Our time down here, this is where it hits the ground, and that's at t is equal to 3. So that is also true. The rock is in the air for only 3 seconds. And that last one, the maximum height of the rock is 45 feet. We already said that. The maximum height there is 45 feet, so that one is also true. So 3 out of these 5 statements were true. For number 14, we want to graph the parabola by first plotting its vertex and then plotting a second point on the parabola. If we're given f of x is equal to 2x squared plus 8x plus 1, so in order to find the vertex, to find our x value, we use our handy dandy little formula over here. X is equal to negative b over 2a. So we need to know what our b and our a are. So if we just put that next to it, so our a is the number times the x squared, which is 2. Our b is the number times the x, which is 8. If we needed our c, we'll list it out there too. So our c is that 1. So now we're going to find the x value of our vertex. So x is equal to opposite b, so negative b, or negative 8, excuse me, over 2 times 2. So simplifying that, that's going to give us negative 8 over 4, or negative 2. So the x value of our vertex is negative 2. Now we need to find the y value of our vertex. So we're going to plug in the x into our original equation to find that y value. So we'll get 2 times negative 2 squared plus 8 times negative 2 all plus 1. So now we just simplify here to help us find that y value. So negative 2 squared is positive 4, so it's going to be 2 times positive 4. 8 times negative 2 is negative 16 plus 1. So 2 times 4 is 8 minus 16 plus 1. And now we just go left to right. So 8 minus 16 is going to give us negative 8 plus 1 is going to give us negative 7. So our vertex ordered pair is then negative 2, negative 7. We can go ahead and plot that point. So we go to the left 2 and down 7 and plot our point. So now this is going to be the lowest point of our graph. So now what we need to do is we need to pick a value next to the x value of our vertex and plug it into the equation to find the corresponding y value. So we have x is at negative 2. We could either do one to the right or to the left, because remember we're going to have a parabola, so whatever we do on one side we're going to have to mirror it on the other. So let's go ahead and just do one to the right. So let's plug in when x is negative 1, and let's see what our y value is. So when x is negative 1, we get f of x is equal to 2 times negative 1 squared plus 8 times negative 1 all plus 1. So we have negative 1 squared is positive 1, so 2 times 1 plus 8 times negative 1 is negative 8 plus 1. So 2 times 1 is 2, so we have 2 minus 8 plus 1. 2 minus 8 gives us negative 6 plus 1 gives us negative 5. So we have another ordered pair at -1, comma, -5. And we can go ahead and plot that here. And then we can, oh, that is not a good line there. Let's try that again. Start to sketch our parabola. And then we have to do the other side. So since we had one to the right, we'll do one to the left, and it's mirroring the vertex. So it's going to be at -3, -5 as well. And then we just sketch that parabola, and we have our parabola drawn. For number 15, we're going to let f of x equal to x squared plus 10x minus 24, and we're asked what are the x-intercepts. And we're just going to enter the x-intercepts in the boxes. And remember, the x-intercepts are just like the zeros that we've already done in two of the previous problems. The x-intercepts are where the graph crosses the x-axis, and once again, we're only putting the x values of our points. Since we have our quadratic function here, we're going to have two x-intercepts. So we can go ahead and plug this into Desmos.com to graph our equation or function and see where the graph crosses the x-axis. So when we do that and we plug in x squared plus 10x minus 24, we get this graph here, and we just care about those 2 points where it crosses the x-axis. And we only care about those x values. So it's going to be at x is equal to -12 and 2. And those are our two solutions. For number 16, we're asked which function grows at the fastest rate for increasing values of x. So we have a couple of hints here to help you. Exponential functions will grow faster than linear, quadratic, and cubic functions. So an exponential function is going to grow the fastest. So if we remember that and it's asking which function grows the fastest, all we want to do is we want to find the exponential function. So we can tell if it's an exponential function if our variable is an exponent. So let's go through each of our choices and see which one of these is our exponential function. So for A, we have 13x squared plus 5x. So it's not A because A is a quadratic. And we care about the exponential, so it's not A. For B, we just have x. This is a linear function, which means it's not exponential. For C, we have 3 to the x power. So notice our variable is the exponent. So this is an exponential function. So it's going to be C. Let's check D just to be sure. So D, we have 6x squared. So D is another quadratic function, which means it cannot be D. C is our solution. For number 17, we're given a tile company is measuring the dimensions of the floors of a kitchen to estimate how much tile is needed. What would be the most appropriate unit to use? So for this question, we just need to think logically about the situation that we're given in order to determine which units of measurements would be best. So if we look at this, we're measuring a kitchen. So it's not going to be huge. It's also not going to be tiny. So thinking about this, do we want to use square miles? Miles would be really big to measure a kitchen, so it can't be A. Let's think about B, square centimeters. So square centimeters, if we're measuring a kitchen, that's going to be a lot of centimeters to have to use to measure that kitchen. So it's not going to be B. And now we're left between square feet or square inches. Because we're measuring a kitchen, and once again, it's a bigger space, but it's not huge, if we're using inches, we're going to be using a lot of inches as well. So the one that's going to make the most sense for this scenario is going to be square feet. For number 18, the graph compares the wait times for patients in minutes of two doctor's offices. Correctly complete the statement. On average, the patients at the first doctor's office waited blank than the patients at the second doctor's office. So if we take a look here, we want to identify the median of each of the office weights. So this one down here for office 1 is going to be, what is that? 21. So that's 21 minutes. Office 2, that is 13 minutes. So now it looks like office 1 is 21 minus 13 minutes more than the patient's weight at the second office. So 21 minus 13 is going to give us 8 minutes more than the patients at the second office. So we can put 8 minutes more. We can actually go ahead and I'll write it down here. Or 8 more minutes. Either or. We'll say 8 more minutes than the patient at the second doctor's office. Remember, you can use your practice test as notes while taking the final. As long as it is your practice test and not somebody else's, while taking the test, look for a similar problem to help you. Be careful, you don't want to get your numbers mixed up. The problems are similar, but with different numbers. If you have any questions, let your teacher know. Otherwise, have a fabulous day and good luck on your final. You will do great.